Hey everybody, welcome back to another lesson in our second unit in calculus. This unit is all about continuity, the intermediate value theorem, and building up towards the derivative. And we are inching closer to learning what the derivative is and how to find one. Today we're going to continue studying the intermediate value theorem. As a review, the intermediate value theorem says that each of the following are true: that f of x is continuous on a closed interval from a to b, that f of a and f of b are not the same, and that some value k is in between them, then there must exist a value c on the open interval from a to b such that f of c is equal to k. Let's take a look at an example. Is there guaranteed a value of x on the interval from 5/2 to 7 such that 1 over x minus 2 is equal to 1/4? For this, we're going to practice being very precise in how we work the problem. The intermediate value theorem is not a difficult concept to understand, but it is on the AP calculus test to ensure that you are able to apply theorems properly. In order to use a theorem, you must establish that what are the preconditions are met, these hypotheses, if you will, before you can get to the conclusion. So we must show that these three are met. I usually don't like to combine things, but you'll see how I kind of combine 2 and 3, but I think it's still fine. Is there guaranteed a value? First of all, we need to establish whether f is continuous on this interval. Well, my f of x, in this case, is 1 over x minus 2. Now, this gives me a little bit of a pause because I know that 1 over x minus 2 has a discontinuity at x equals 2 because it would be a divide by 0. However, 2 is not on this interval because 5 over 2 is 2.5. So we're good there. I'm going to say then, and that's the only discontinuity of f, so I'm going to say f is continuous on, I need to establish it on the closed interval, and that's important. You need to establish continuity on a closed interval to apply the intermediate value theorem. Let's find out what f of 5/2 is. F of 5/2 is 1 minus 1/2, 1 over 1/2, which is 2. I'll show the work. 5 over 2 minus 2. I'll get a common denominator and make this 2 4 over 2. So this becomes 1 over 1 over 2, and 1 over any fraction is simply its reciprocal, making the value 2. Let's see what f of 7 is. F of 7 is 1 over 3. The value 1/4 is not, oh wait, I'm sorry, it's not 1 over 3, it's 1 over 5, in which case the value of 1/4 is in between 1/2, between 2 and 1/5. So I'm going to say that f of 5/2 is greater than 1/4, which is greater than f of 7. And I'm going to claim that I've established this by showing each one here. And also it's kind of implied by these greater than symbols, but that is part of the theorem as it's written, so I want to make sure we address all three parts. All right, since I've established that, I can now conclude by the IVT, and you can abbreviate intermediate value theorem IVT, and most people too. By IVT, f of x equals 1 over x minus 2 equals 1/4 for some value x on the open interval from 5/2 to 7. All right, before we leave this, I want to go over how this would be graded by myself or an AP grader. First of all, they're going to look and see, did they establish this? Okay, so that's a check. Next, they need to establish in some way these two characteristics here. And we've certainly accomplished that by evaluating them and showing that. And finally, they want to see that you have cited the theorem. And that is what is necessary to get full credit. Okay, now for your turn, I want you to make sure that you follow each one of those steps, that you develop the preconditions, check them properly, and then draw a conclusion. Pause the video and give it your best shot. All right, let's see how you did. Okay, so I'm looking for the interval from negative pi over 4 to pi over 4. F of x is cotangent of x, which is the cosine of x over the sine of x. So we have division here. Anytime we have division, we know there's a possibility that we could divide by 0. So we need to see, is there ever a time when the sine of x is equal to 0 on this interval? Well, the sine of x does equal 0 when x is 0. So I'm going to say f is not continuous on the interval from negative pi over 4 to pi over 4. So the IVT does not guarantee a value where f of x equals 0. There's just absolutely no guarantee whatsoever. Now, please don't misunderstand me. I'm not saying that f of x won't equal 0 on that interval. If I picture cotangent, I'm pretty sure it doesn't, actually. But the IVT is not about saying that a 0 doesn't, our value doesn't happen. It's about saying when we know that it must. And in this case, I do not know. I do not have any information. I could use algebra to try and figure out the answer to that question, but the IVT does not answer it. So it just simply doesn't apply. Okay, you have another practice problem. So pause the video and give it a shot. Okay, so for this one, we're trying to figure out if this polynomial here, which I'm going to call f of x, we're trying to figure out if f of x is ever equal to 1. X squared minus 3x minus 4. Well, f is clearly continuous. It's a polynomial. No division or anything like that that could cause problems. So f is continuous on the interval from 0 to 5. Okay, so it's continuous. That's good. Let's figure out what f of 0 is. F of 0 is a negative 4. Let's figure out what f of 5 is. That's 25 minus 15 minus 4. That is, what was that, 6? Okay, so clearly this 1 is in between those two. So since f of 0 is less than 1, which is less than f of 5, I'm going to say that x squared minus 3x minus 4, you could just say f of x, I guess, equals 1 for some x on the open interval from 0 to 5 by the IVT. I should probably say by the IVT. Didn't say that, but you know, just somewhere in there, I want to make sure that I cite the theorem. That's an important part of doing mathematics. Is when you use a theorem, you need to cite the theorem. It's your evidence. It's your proof. All right, practice 3.4. What is the fewest number of zeros of the continuous function f with selected values shown in the table? All right, give this one a shot, and then we'll go over it. Okay, so this is a really very popular kind of question on the AP calculus exam. We'll oftentimes be given a table of data and be asked to determine what is the minimum number of times that some value could occur. Again, the IVT never says that something won't happen many, many times. It just guarantees it happens at least once. So when I look at this, first of all, I'm going to say that f is continuous. Continuous. We could say everywhere. It says it's a continuous function, so I'm just going to say f is continuous. I could say 0 to 5. I could say everywhere. Negative infinity, infinity. All those things would be appropriate, but just somewhere we want to make sure that we considered that, even if it is just pretty redundant. We're just, don't say, well, they said it was continuous, so I shouldn't have to say it. No. You better say it. Trust me. Okay. Now, let's see here. I want to know where it could have a 0. That's when f of x is 0. Well, it looks like this region here, right? Definitely. And then again over here. And I don't know why. It's funny that, I think I made this example, but it happens to be the same. I don't know why, but it seems like every time I do a practice problem from the AP exam like this, there's always 2. I don't know why. There's always at least 2, but I rarely ever see just 1. So look carefully, okay? So I'm going to say that f of 1 is greater than 0, which is greater than f of 2, and f of 3 is less than 0 and less than f of 4. So that's my documentation that I have established 2 different intervals that don't overlap where the IVT guarantees the existence of a value. So therefore, by the IVT, f must have at least 2 zeros on the open interval from 0 to 5. So just a couple of things to note here. Again, I want to hit this again, that this idea that it's at least 2, I don't know how many. I know that we were positive when x equal 1, and then when x equals 2, we're down here at negative. But I don't know if that graph doesn't come down and then just go up, 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 and then come down. It might cross that axis many times, right? But I know that it has to happen at least once. Other things I want to point out, I did not go through the step of saying f of 1 equals 1, f of 2 equals negative 2. I just merely skipped straight to there. I can confirm that that is okay. That gets full credit. So that's one of the few times that you'll see me kind of combine 2 preconditions. But as long as I'm saying greater than, then it's definitely implied that they're not equal. All right. There's a second part we need to go. And I think we already covered it, actually. Is it possible that f has more zeros than the amount of your answer in part A? And the answer is simply absolutely. The IVT guarantees the existence of 1 on that interval from, say, 1 to 2. It does not say that there won't be more than 1. We just know that it has to be at least 1. And so that's it for today. I just want you to practice, take this time to work on your assignments, and please document properly. Practice spelling out using the theorems. Do not abbreviate, except for saying IVT, but don't skip any steps, because if you skip them now, you'll skip them when it counts. So go through all 3 parts every time. Okay, take care.